Hey guys, I'm Keenan Castro,
I'm Katie Wong.
and our team is called the KatsuControllers.
Our project, the GoPro, is a smart plant care mechatronic system that ensures the well-being of indoor plants and reduces the problems that first-time plant owners face.
First, they no longer have to keep track of the amount of moisture that is required for each and every type of plant. There's a lot of different types of plants for first-time plant owners to take care of, so it can be very difficult for them to be able to understand and track which plant requires which amount of moisture. Our system is able to take care of that by being able to differentiate between different types of plants. Second, it's important to ensure the plant is neither underwatered nor overwatered, as it can significantly hinder the growth and development of the plant. Our system is able to ensure that the plant is watered at its specified soil moisture level, solving this problem.
Our goal for this project was to make it relatively cheap as possible, and we set a budget around $150. Due to this limit, this affected other design specifications such as its build volume. Due to its compact design, the projected weight of this project was to be a little under 10 pounds, and the flow rate of the water pump used in this project is approximately 0.35 gallons per minute, according to its data sheet. With the NRF microcontroller, the main components used in our project are a capacitive moisture sensor, an RGB color sensor, an ultrasonic sensor, and a water pump. From semi-moist to very moist, the stickers colored red, green, and blue are stuck on the bottom of the plant's pot. The plant would then be placed on a platform directly above an RGB color sensor. Once the color sensor identifies one of the 3 colors and the moisture sensor has been inserted into the soil, the microcontroller will take moisture readings of the soil and compare them to moisture values for the specific color. The colors red, green, and blue correspond to 20, 40, and 60% moisture needed in the soil. These moisture percentages were obtained through prior testing with the capacitive moisture sensor. If the moisture content of the plant exceeds the limit, then the microcontroller will continue to monitor the soil until it reaches below the limit. Once this happens, the water level of the tank adjacent to the plant is measured by an ultrasonic sensor. The water level of the tank will be indicated by 3 LEDs: green, yellow, and red. As long as the water level of the tank is slightly above the water pump in the tank, the pump will deliver water to the plant for 1 second and then wait for 30 seconds for the water to distribute evenly into the soil. This will cycle repeatedly until the required moisture level is reached. If the water level is close to the pump will stop and the NRF will start to play a noise along with a blinking red LED to indicate that the tank needs to be refilled with water before pumping more water.
Here we're demonstrating the use of a toggle switch on the front panel to provide the user with the ability to switch between different plants in our system.
Most of the concepts that were applied to this project were taught in the mechatronics course, such as using a Darlington IC to drive multiple LEDs and implementing state machines for our project. One important lesson that we learned was we couldn't use a voltage divider to drive our water pump because it couldn't provide enough current.
If we had more time, we provide the user with a much more robust user interface by allowing them to be able to save their own color and moisture level profiles. And we'd probably use the LCD screen and possibly a rotary encoder to allow this ability to happen. Second, we'd look into completely separating the electronic components from the primary space for the plant base, and the water tank, as this would significantly reduce the hazard of water damage to the actual components.
This concludes our presentation for our mechatronics project.
Thanks for watching, and we hope you enjoyed it.